I'm Paola Cappellaro. I'm an assistant professor of nuclear science and engineering, and I'm a member of the research laboratory of electronics, and my research group is the quantum engineering group. I'm originally from Italy, and I came to MIT to do my PhD work, and I came here to the nuclear science department, and I got involved into quantum mechanics, which really fascinates me. Much of the theory behind what I'm doing is very much physical theory, but I'm trying to use all these recent, if not new law of quantum mechanics, and trying to create some practical devices. So it's really trying to take what is a physical theory, quantum physics, and transform it into more engineering. My group, which is the quantum engineering group, is sort of divided into two main research directions. So on one side, we have a project or a set of projects which are interested in studying a particular quantum system, which is a color center in diamond, with this defect in diamond, which is comprising an electronic spin. This first project is looking at one single electronic spin and then from there grow up. And the second set of projects is instead trying to look at many spins, which are more difficult to control because there are so many of them and they interact one with the other, and then trying to arrive at the point where it will be possible to take such a complex system and really manipulate each individual spin one at a time. The goal is to have, if you want, a large number of individual units, a large number of individual qubits, which can be the basis for a quantum computer. What is good about my research is that fundamentally many of the things that I'm looking at are in some sense very simple. So I'm really looking at the very basic principle of quantum mechanics, and so that's really helpful when I talk to students because it's good to go back and really revisit all the basics to have a deep understanding. And having to explain it to somebody else who might be amazed by these concepts which are not intuitive sort of makes myself trying to understand it even better. It's sort of a bit different teaching to undergraduate or to graduate student, but I think that like both of these two types of teaching are really interesting and enjoyable. It's really great to have students who really are not only knowledgeable, but they're also smart, curious, and then they're really independent. They can propose their own research project and they're able to sort of generate new ideas. So I think that's really what is great. Since I've arrived to MIT and RLE in particular, they've been helping me out in many different ways. RLE is so much like, if you want, at the center of MIT, both as location and also for being such a big lab. There are so many people who are affiliated to RLE, and it's very easy to get to know other people, to start collaboration and start discussing. The best way to stay current on what's going on around you, and it's easily done here at MIT, is just to talk to other people and interact with other people in the field. What is really exciting me in being here is the fact that I can really do research in things that I'm passionate about, and I am in this extraordinary community so that I can bounce off ideas with other people and really have the feeling that everybody is really working toward making progress. This feeling that everybody is really believing in what we're doing and really trying to do their best because they really think that what we're doing is important is really the thing that is sort of motivates me, and it's really the feeling which I think is unique to MIT and RLE.